Thank you very much. Good afternoon, everyone. As said, my name is Stephan Harkema. I'm Program Manager for Sustainable Electronics at Holst Center. Holst Center is an independent research institute located in the Netherlands, Eindhoven, at the high-tech campus. So I would like to go into the topic of recycling of in-mold electronics. So I will first briefly introduce in-mold electronics and then go into related topics and finally show you what we can actually do on this topic. So, in-mold electronics, to perhaps remind you, is a rigid form of printed electronics where the rigidity comes from a lot of plastics, basically. So in the first stage, we do printing of the electronics with silver ink, for instance. We then do a thermal forming or high pressure forming step in order to get to the shape of the product. Then after cutting, there's an injection molding step, which adds quite a bit of an additional plastic and then generates the rigidity of the item. And then after taking it out of the injection molding tool, you'll have this product. So here an example, in-mold electronics part, which was developed together with Alps Alpine. On the bottom left, you see a mid-console with an element which we made for them, which falls into the category of in-mold electronics. So it contains components, SMD components could be LEDs, could be chips, could be resistors, silver, and then combined with a lot of plastic. This is a challenge to recycle, and this is why we went into this topic. So to decarbonize a step further in mold electronics, there are many things that you can improve. You can look into the production, which has also been discussed in previous presentations. You can use green energy, you can reduce the usage of resources, you can reduce production waste and also have a better processing method in order to use less energy during that. Also, you can make use of different materials, move away from petrochemical materials towards bio-based materials or recycled materials, which become more available worldwide. Nevertheless, it is quite tricky to close the loop for manufacturing of in-mold electronics because you're stuck at end of life, because you have a part which seamlessly integrates, but then in the negative form, the plastics, the metals and the components, also thus capturing the critical raw materials that may become an issue for our supply security in the future. We had a look into what recycling of hybrid printed electronics in general would mean. We visited a recycling plant, a collection plant, and we noticed that this might have been a fluke, but we noticed that there was a foil which looked like printed electronics on the side of the conveyor belt, like it floated off at one of the first stages. So you have the collection is put onto a conveyor belt. You might have methods to separate the iron from the metallized plastics and whatnot. You have a shredder, and try to imagine hybrid printed electronics being part of a shredder. You might have stretchable substrates which might clog up the shredder. You have these floating, these very lightweight elements that go into the shredder, might not stay there. So this is also an issue, having more or less a recycling industry that's focused on recycling of plastics and PCBs and the combination thereof. But what happens if you have hybrid and printed electronics in there? There's a lot of issues related. So we have metallized mixed plastics. Ultimately, the end goal or what happens will, you cannot recycle it so easily, so it will be incinerated for the recovery of energy. Often more is added, more plastic is added, which makes the problem even worse. So we have a metallized plastic with a high plastic content. If you want to bring it to metallurgy for the recovery of the metals, then you face having a lot of plastic, meaning you have to burn a lot of plastic before you get this low amount of metal. So the amount of metal, the fact that it is low, is favorable for our global warming potential and the environmental impacts of hybrid printed electronics, but it is a problem in the recycling. So for PCBs, it's easier having, let's say, 30% of copper. Copper you can separate from other waste more easily using eddy current, for instance. It is a challenge to recycle. So what we did is we had a case study for in-mold electronics recycling, and we used our lab-based lighting devices in order to study the details. So we used a mono polymer device, mostly consisting of polycarbonate, a very typical polymer for in-mold electronics. So 98% by weight was